Good morning, students. In some previous lecture, we have started the second topic, that is the mechanical properties of a fluid. Up to the last lecture, we have completed the factor affecting on the surface tension of a liquid as well as the factor affecting on the angle of contact. Which are that factors? Factors are like temperature of a liquid as well as impurity added to the liquid, or nature of a liquid is in contact with the solid. So today we have to start the next topic. That topic is like the excess pressure across the free surface of a liquid. That means in front of you, you have considered the three cases: case 1, case 2 and case 3. So this will be the first case, this will be the second case, and this will be the third case. As we all know that the pressure is equals to force per unit area. We have the applied force per unit area. So in each case, as we have considered, the surface area of this container will be a same. Okay, in first, second and third case, the surface area of the beaker containing the liquid have the same surface area. And we have the consider the two molecules. The molecule A is just above the free surface of a liquid and molecule B is just below the free surface of a liquid. So now consider in a first case, as A is just above the free surface and B is just below the free surface of a liquid. So now the particle is considered at this location have the force towards tangential force on the right hand side and tangential force on the left hand side have the same magnitude but opposite in direction. So they are balance each other and they are cancels each other, and surface will be a plane. Surface will be a plane. Therefore, the pressure applied by the atmosphere is vertically downward, that is FA, and pressure applied by the liquid is vertically upward, that is FT, also have the same values and they are cancel each other. Therefore, as they have the pressure have the same values, as we all know that pressure by the atmosphere and pressure by the liquid, that is the tangential force, have the same values. So divided by the surface area, as surface is the same, so they have the FA upon A is equals to FT upon FA. Therefore the pressure just above the surface and pressure just below the surface, that is FT, have the same value. So atmospheric pressure, which is just above the free surface of liquid, and pressure due to the surface tension, that is PT, have the same value. So we can say that in a plane surface, the pressure below and above the free surface of a liquid have the same value. So surface will be a plane. Okay, so it is considered in a first case. Now consider in the second case. Okay, so as surface will be a concave, then now we have considered at a point B, the force or tangent drawn to the liquid surface is like this towards the right, and tangent drawn to the left will be like this. So their resultant force is vertically upward. That resultant force is called as a FT. And the force exerted by the atmosphere on the liquid surface is considered to be a FA. So now where we can consider that is FA is greater than the FT from the diagram. Okay, as surface will be a concave, so we can easily conclude that force applied by the atmosphere is always greater than the force applied by the surface tension of a liquid. As surface area of both surface have the same value, so now if we are divided by the same value, that is A, and also we have the A, so there is no change in the relation, so easily we can write the pressure just above the surface, that is FA is greater than the FPT. Okay, that is the pressure due to the surface tension have the smaller value. So pressure by the atmosphere have the larger value as compared to the pressure due to the surface tension of a liquid. So pressure of a concave side is always greater than the convex side. So pressure above the free surface of a liquid is the greater than the below the surface. So we can conclude that pressure on the concave side is always greater than the convex side. So keep in mind this statement, that is pressure on the concave side is always greater than the convex. From the diagram we can conclude that is FA is greater than FT, therefore PA is also greater than the PT, that is pressure just above the free surface of a liquid have the larger magnitude as compared to the pressure just below the free surface of a liquid. So now consider in a third case we have the convex surface. So now as we have drawn the tangent to this point, so this will be a tangent towards the right and tangent towards the left. From diagram we can conclude that their resultant should be vertically downward. Their resultant should be vertically downward, that is FT. Their resultant force due to the surface tension of a liquid, but as well as atmosphere pressure is also vertically downward. So as we can conclude that the maximum force is towards the vertically downward, and still we have the surface like a convex. So from this diagram we can conclude that as pressure FT, pressure towards the FT have the plus pressure due to the atmosphere, is both are added. So we can consider that pressure just below the surface of a liquid have the larger value. Pressure below the free surface of a liquid have the greater than the above the free surface of a liquid. So easily we can write that is pressure on the concave side. This, if you consider particle B is on the concave side and particle A is on the convex, so pressure along the concave have the larger value. So where PT have the larger value as compared to the PA. Okay, so where in third case PT is greater than the PA, therefore again we can conclude that pressure on the concave side have the larger value and have the smaller value along the convex. So pressure just below the free surface of a liquid have the greater than the pressure just above the free surface of a liquid. So when surface will be a concave, the pressure is greater at the above, and when surface will be a convex, the pressure is greater in the below of the liquid. So keep in mind that these cases. So now we can proceed for the next point, that is the explanation of a formation of a drops and bubbles. So I think at your childhood, now also you are the child, you have performed the bubbles, soap bubbles at the homes. Okay, so when you have to dip in the soap solution and taken out, and when you have blow that surface or that surface film, there will be a formation of the bubbles. Such a bubbles have the initial volume or their radius will be small. With the respect to time, it will be increase their surface area, and as soon as at a certain time they will be lose their spherical structures and they will be a blowout. Okay, so they will be lose their spherical structures. So why this happen? So now consider that is pressure inside the spherical shape. Okay, what will be that bubble or drops? Now first we have to consider about the drop, then we can go to the bubbles. So Pi is a pressure inside the spherical bubble and Po is a pressure outside the spherical shape. Okay, so now what will be the pressure inside that bubble? We have the Pi, or drop we have the Pi, and pressure outside the spherical shape we have the Po. And up to the which condition these have the spherical structure? When the Pi is equals to the Po, then there is a no formation of the bubbles. Okay, keep in mind that spherical shape is consisting up to when the pressure inside should be greater than the pressure outside of the shape, then this spherical structure will be valid. When this the Pi is equals to the Po, then they will be lose the spherical shape. Okay, so keep in mind that Pi is not should be equals to the Po. So continue to our topic. So excess pressure to the formation of that bubble or drop, we should have the condition that is Pi should minus Po. It is nothing but the negative value should have the positive value, so we can call as a excess pressure. It is the extra values, so it is called as a excess pressure of a Pi minus Po. So now therefore the radius of the sphere is increased from r to r plus delta r. Okay, initially we have the dark line shows the at t equals to 0 seconds. So t equals to 0 second, after a time is equals to t seconds. We have the initial value and we have the after some time, that is the t seconds, there will be increase in a shape of the bubble and increase in a radius will be delta r. So total radius will be r plus delta r. So initial radius is r, and the radius before lose that spherical structure, they have the radius is r plus delta r. So now as where delta r is very small, so there is no large increase in the shape of the spherical bubble or drops. They have the smaller increase in radius, so delta r is considered to be a very small, so that inside pressure remains almost constant. So increase in surface area, as we all know that the radius is increases by the delta r values, so increase in surface area is called as a final surface area minus initial surface area. So dA is equals to surface area of the sphere, that is 4 pi r square. So final radius is r plus delta r and initial radius is r, so you can write 4 pi r plus delta r bracket square minus 4 pi r square. So now using the expansion, that is a plus b bracket square, that is we have the value that is a square plus twice of AB plus B square. Come to the our expansion, that is R will be a and delta R be the B. So we have the R square plus twice of R delta R plus delta R square minus R square. These are the values of this expansion of the R plus delta R square. So now from this equation we can conclude that where we have the values like we have the minus R square and plus R square get cancelled. So twice of R delta R and delta R square. So as we have considered that is delta R is a very small. So as delta R is a very small, then delta R square is tends to 0, is not exactly equals to 0, but it tends to equals to 0. How most of the students ask about the how this is possible. So consider the one example, like if we have the value 0.2 and we have taken the value is very small, okay, so 0.02 is a small values and we have taken its square. So what is the value is 0.0004. okay, it is the 4, and we can easily conclude that the answer is very small as compared to the A. So what will be the A square is equals to what will be its value, that is 0 point something. So we can conclude that A have the greater magnitude as compared to the A2 from like when A have the smaller value. Okay, when this case is possible, when A have the less than the 1 value, then and then this case is possible. So okay, so as we have considered that is delta R is a very small value and delta R square is tends to 0. So that means delta R square is approximately equals to 0. Delta R square is approximately equals to 0. So now put in the above equation. So as we have considered that this term is cancelled, this term is also considered cancelling each other, and this term is tends to be a 0. So only this term will be remains. So 4 multiplied by 2 will be 8 pi R into delta R, equation number 1. This is the equation number 1. So now comes to the second page. According to the relation between the surface energy and the surface tension, we have learned about this surface energy and surface tension. We have considered the work done to increase in the surface area. That will be considered as that work done dW is equals to the surface tension of that surface bubble or drop multiplied by the increase in a surface area. So now consider the such a relation. We have the T is equals to dW upon dA. dW is surface energy and dA is an increase in a surface area. dA is an increase in a surface area. So now work done is equals to T in bracket 8 pi R into delta R, equation number 2. This will be work done or surface energy. But by the definition of a pressure, as we all know that excess pressure is equals to excess of a force upon area, or nothing but the force is equals pressure is equals to force upon area. So excess force is equals to the excess pressure multiplied by the area or surface area. So by the definition we can write dF is equals to in bracket Pi minus P out, excess pressure inside that drop or bubbles, that is Pi minus P out multiplied by the area of that sphere. So what is the area? It is the initial area of that drop or bubble, that is dF is equals to Pi minus P out multiplied by the 4 pi R square. So as this excess of increases the surface area of a sphere which given as a work done, what will be the force? As we all know that definition of work done, that is work done multiplied by the displacement is nothing but the force multiplied by displacement is nothing but the work done. So by definition dW is equals to dF into delta R. So what is the excess pressure from equation number 2? That is the last page. So we have the Pi minus Po multiplied by 4 pi r square into delta R from the equation number 3. So consider the equation number 1. What is the equation number 1? That is dA is equals to 8 pi r into delta R. So comparing equation number 2 and 3rd, we can given the equation, that is T 8 pi r into delta R is equals to Pi minus Po 4 pi r square into delta R. So from this equation we can cancel some terms, that is delta R and delta R get cancelled, where R and R square so get cancelled, only R is remaining. We have the pi and pi get cancelled, 4 ones are 4, 4 twos are 8. So remaining terms is like this, the Pi minus P out is equals to twice of T upon small r, where we can easily write the excess pressure. The excess pressure of a bubble is equals to twice of T. What it means T? T is the surface tension upon small r. Small r is the initial radius of the sphere. This equation is called as a Laplace law for a spherical membrane or for the drop. Okay, consider this equation is valid for only spherical membrane or a drops. What is about the drop? Because in case of a drop, the inside portion will be filled with the any substance other than the air. So free surface of liquid in such a drop, we have the only one value. But in case of a bubble, it will be a hollow. So in case of bubble, inside is also air. In case of a bubble, we have the inside air and outside also we have the air, but still they have the excess pressure. So in case of bubble, we have the two surfaces, free surface of a liquid. In case of a bubble, we have the two free surface of a liquid, but in case of a drop or spherical membrane, we have the only one free surface of a liquid. So this equation or this Laplace law is valid for a spherical membrane or the drop. So now in case of a soap bubble, there are the two surfaces in contact with the air, so we can consider the two free surface of a liquid. Therefore the equation number 1 is becomes dW is equals to T multiplied by twice of dA. So increase in surface area will be twice, because we have the two free surface of liquid. Therefore the equation will be a 16T pi r into delta R. So comparing equation number 2 and 3 will becomes like 16T pi r into delta R is equals to Pi minus P out 4 pi r square into delta R. So similarly delta R and R pi and 4 ones are 4, 4 fours are 16. Thus cancelling term, after that we can conclude that the equation is Pi means excess pressure in case of a bubble is equals to Pi minus P out is equals to 4 times of the surface tension upon the initial radius of the bubble. So we can easily given this equation. This equation is valid for the spherical membrane or the drops, and this equation is case of the bubbles. Okay, so in case of bubble we have the two free surface of liquid, but in case of a membrane we have the only one free surface of a liquid. So examination they may be asked the excess pressure of a drop or spherical membrane, or they may be asked about the Laplace law in case of a bubble. So first see about the which point they have asked in examination and go through the same. If you have in examination they ask about the drop and you have written about the only you have skipped this stage. Okay, if you have skipped this stage and we have multiplied by directly 2, we have skipped this stage and we have written directly this stage, then we will not get the full marks because we have skipped this stage. And if you have ask about the drops, then it will be easily we can write this term. So if you have written the up to this stage and but examination ask about the only this stage, it will be extra, but we will be get the full marks up to this stage. Okay, so first see about the exam what about the up to the which point they have asked in a examination, then after the attempt the same equation, that is Laplace law for the bubbles and Laplace law for the drops or spherical membrane. Okay, thank you. We will be continuing in a next lecture or next video.